Hi, good afternoon, everyone, and thank you for taking your time to join us today. My name is Soma Sankaran, and I'm the VP of Sales and Marketing with DenseLight in Singapore. So today's webinar is part of the ITAP 2020 exhibition. I'm happy to let you know that DenseLight is a silver sponsor of this event. Before I start, I would just like to inform the audience that this portion of the presentation or the webinar is being videotaped. So, and later we will send out the link to everyone so that if you want to review it once more, you can do so. We know that Industry 4.0 is the ongoing automation of industrial practices using smart technology. This includes the integration of M2M or large-scale machine-to-machine communication, and B, IoT or the Internet of Things for increased automation, improved communication, and self-monitoring. For today's talk, I would be introducing DenseLight and how DenseLight can help you deliver higher performance and cost-effective solutions through the integration of photonics, which then can be embedded as sensors on machines and industrial infrastructure for IoT. I'm happy to take questions, and if you have any questions, you can type into the chat box or the Q&A box, and I will open up the mic to the audience at the end of this presentation. So, my apologies. First, I'd like to talk a little bit about DenseLight. DenseLight is a Singapore photonics semiconductor company with a 20-year track record of servicing the global datacom and sensing markets using innovative photonic light source technologies. And all these are developed locally here in Singapore. We provide a one-stop design and manufacturing of optoelectronic devices and integrated photonics solution. We have more than 100 people in R&D with new product development and high-tech semiconductor manufacturing expertise. We have a global mix of engineers coming from all over the world, in fact, 11 nationalities. We have 2 official sites, one in China, and our global R&D team, as well as our indium phosphide wafer fab, is based here in Singapore. The company's main technology focus is on indium phosphide, optoelectronic semiconductor device fabrication, and the integration of indium phosphide to silicon photonics. We have a global customer base, almost over 150 customers in 26 countries, servicing the application fields of telecoms, biomedical, instrumentation, industrial, defense and security, as well as data centers. And we are supported by a network of business partners located globally around the world. And this includes people in supply chain, regional distributors, manufacturing partners, as well as silicon foundry partners. So DenseLight is vertically integrated. As you can see from the presentation, we provide end-to-end photonics from the design to wafer fab manufacturing to device production. In new product development, we have a team of more than 20 PhDs, very strong in optoelectronics, device physics, design, simulation, device fabrication, as well as testing to meet demanding industrial-grade qualification standards. The wafer fab clean room is actually situated in Changi, which, if you know Singapore, is actually quite close to the Singapore airport, Changi Airport. In manufacturing, the DenseLight clean room is run by a team of very experienced semiconductor industry veterans with many years under their belt in process R&D and volume wafer fab manufacturing. The two main markets that DenseLight serves is the photonic sensing market and data communication market. I will talk a little more about these markets in my next two slides. We'd like to think that DenseLight is part of the ecosystem that generates, transmits, and detects photons, which means that almost everything around us is in some way enabled by the work we do in DenseLight. Donna Strickland, the Nobel laureate, remarked that photonics is going to be the technology of the 21st century. And as you may know, many of us just celebrated the Day of Photonics this week. All this points to the importance of photonics to our future, and DenseLight is excited to be part of this revolution. So let me talk a little bit about the markets that DenseLight participates in. The photonic sensing market that we serve covers a wide field of application. And from this slide, you can almost recognize many of the sensing markets and applications that are directly relevant in playing vital roles for IoT sensors in Industrial 4.0. One of the biggest markets in sensing is the test and measurement market, and this includes OTDR, components and material testing, fiber bright grading sensing for machinery and structural health monitoring, gas sensing and in metrology. And we serve this market with products like ELEDs, DFB lasers, broadband superluminescence LED or SLEDs, and narrow line width lasers. The medical business is not as big as test and measurements, but DenseLight has established a foothold through our products for applications such as OCT or optical coherent tomography, surgical tool pressure sensing, and continuous glucose monitoring. One of the up and coming areas is LiDAR, which includes wind turbine LiDAR for wake steering, and also, of course, the big market of automotive LiDAR. We are already working with several wind LiDAR manufacturers to incorporate our FPGL and our narrow line width lasers into their system. Automotive LiDAR is a little more into the future, where we are currently developing customized SOA, gain chip, and indium photonics ICs into the auto LiDAR module. Interestingly, you will notice later in one of the slides that some of these devices that we are developing for automotive LiDAR are also needed in coherent communication solutions. In the field of structural health monitoring, it involves using fiber itself for both telemetry as well as sensing for structural integrity, for sensing temperature, humidity, pressure, vibration, and positioning, and is most applicable to a wide range of industrial machineries and small to large scale infrastructures. And we have specific products in our portfolio to support such applications. Guidance and navigation is one of our larger markets, and this is a market for a lot of our incoherent SLED light source and photonics IC solution, and it is primarily for fiber optic gyros, which are used in unmanned aircraft, drones, and industrial robots. Last but not least is DAS, or distributed acoustic sensing, where using a narrow line with laser, the entire length of the optical fiber is powered up to tens of kilometers in length, and it instantaneously becomes tens of thousands of acoustic and vibration sensing points spaced maybe a few meters apart. Such distributed acoustic sensing capability has found many applications in railway monitoring, in pipeline security, that's oil pipeline security, and in asset protection, which primarily is perimeter security. So to recap, Industry 4.0 requires a large-scale machine-to-machine communication, and it requires solutions for IoT, for increased automation, improved communication, and self-monitoring. While the main focus of this webinar is really Industry 4.0 and IoT, I'd like to point out that DenseLight also plays a role in the machine-to-machine communication parts, which means that once you send the data has to be transported and stored and processed and transported again. So DenseLight participates in the transport of a lot of this data with products for data centers, as well as 5G antenna front haul fiber feed. The DenseLight portfolio for Datacom includes lasers for photonics IC solutions, SOA and gain chip for coherent transceivers, high power and 25G DFB lasers for 5G applications, and various transmit lasers for data center transceiver applications. So, how is DenseLight enabling the different technology platforms that are used in the industry? DenseLight is positioning itself to be platform agnostic, or in other words, platform independent laser solution provider. Every chip that we manufacture supports both conventional and customer specific technology. At the top of the display of the presentation, labeled A, you will see that these devices could be assembled into traditional packages such as TOSA and BTF packages. And the BTF packages or TO-CANs are subsequently integrated with other conventional micro-optics to form the photonic circuitry for a transceiver or sensing module. So essentially, DenseLight has chips that can go into these modules. Alternatively, if you look at B, it could be assembly in a laser micro packages, which many customers are doing for subsequent grating coupling into silicon photonics. And finally, of course, our chips can be used in the latest direct flip chip technology bonded onto silicon photonics wafers. So hence, DenseLight is able to service the different assembly platforms. And this is because we have our own device design and wafer fabrication capability. So what is driving the solution of the future? The answer can be found in this maxim: more for less. Customers are demanding more speed, more connectivity, more port density, more sensing points, more signal fidelity. And they want this for less cost, less energy consumption, less footprint or smaller footprint, and of course, less time or faster time to market. For instance, with the rollout of IoT, the number of sensors per square area increases. And in turn, to manage the data from these sensors, mega data centers supported by fat pipe fiber bandwidth and 5G deployment are needed to receive, transmit, store, and process vast amounts of data. And DenseLight believes that photonics integration is the key solution to this more for less maxim. At the photonics hardware level, the more for less maxim is driving the change from traditional micro optics and unit by unit assembly approach towards wafer scale integration of essential optical building blocks using silicon photonics wafer level processing. However, as silicon cannot emit light, silicon photonic circuitry will require the integration of laser light sources. So this is a slide that we took from a Yole report that illustrates the nature of the ecosystem for enabling silicon photonics solution. And this is primarily from the perspective of realizing transceivers for datacom application. The equivalent or the ecosystem for realizing the equivalent embedded sensing optical engine is somewhat similar, but it is far more complex due to the much larger variety of sensing application scenarios. So from this diagram, you can see to realize a silicon photonics transceiver, the transceiver manufacturer would need to navigate this relatively complex ecosystem, have the technological know-how to engage the silicon foundry or the silicon photonics foundry, the fabless design houses. They have to line up various critical epitaxial and the indium phosphide optoelectronic suppliers. So in other words, they have to deal with different people in different parts of the supply chain. Hence, it is with our customers' interests in mind, DenseLight went about developing our DPHI packaging platform. The aim of this was really to work with our partners to provide a one-stop shop solution. The customers then can spend or can avoid spending time dealing with different people or different parties along the supply chain, and instead focus on delivering value to their customers while we deliver the engine solution to them. And as you can see, this also would allow our customers to have shorter time to market. So what is DPHI? Over the course of the past 3 years, DenseLight has developed a suite of key hybrid integration packaging technologies for indium phosphide actives on silicon photonics wafers to realize silicon photonics based optical engines. We have trademarked this as DPHI, which stands for DenseLight Photonics Hybrid Integration. With DPHI, we can help customers accelerate their transformation from previously using traditional optical assembly platforms to the new silicon photonics hybrid integration platform. This slide provides an illustration of how DPHI packaging technology can be used to realize a 400G FR4 optical engine for data center interconnects. And this same illustration can be also used for optical sensing engines, as we will show you in the couple of slides later on. So it first starts with the indium phosphide actives from DenseLight's indium phosphide fab, We have standard products, or we can customize products for certain applications or your application needs. We then work with our silicon foundry partner to fabricate the silicon photonics wafer, which is in line with your requirements. Then, using DPHI manufacturing process that we have developed, we do the back-end processing, the wafer scale flip chip bonding of the indium phosphide actives onto silicon photonics wafer, and finally the testing and singulation into individual optical engines. These engines are then ready for use by the customer, the transceiver manufacturer, or the embedded sensing manufacturer for their system and production operations. So, as you can see from this picture, how DenseLight's DPHI technology can be applied to sensing photonics to enable a greater level of integration to increase port densities as well as greatly reduce size. On the left of this diagram or this chart, you can see that the present day situation of a traditional sensing photonic circuitry. This can be rather bulky due to the relatively large size of its fiber optic components or the free space optical components. On the right, we show that DPHI technology integration can vastly and greatly reduce the size by replacing traditional optics with silicon photonics waveguide-based components. The end result is an SOE, or sensing optical engine subsystem. And with the appropriate electronics and suitable enclosure and of course testing, it is ready for field deployment. This slide shows another example, or shows two examples of miniaturization of sensors using DPHI. On the left, you can see an example of a present-day super broadband incoherent light source, which is traditionally constructed by combining the spectrum of multiple wavelength sources, and how it can be greatly miniaturized by our DPHI technology. The diagram on the right shows how an 8-channel multi-wavelength laser light source, again traditionally assembled with discrete package lasers and fiber optic components, can be greatly miniaturized with DPHI sensing optical engine. So to summarize the presentation, with photonics integration and the resulting miniaturization, there is a growing trend in embedded photonic sensor applications. We are seeing many such new applications from active interactions with our many customers worldwide. This includes embedded glucose monitoring sensors under the patient's skin, embedded strain and vibration sensors into fiber composite structures for wind turbine blades, as well as in airframe of commercial aircrafts, embedded temperature and pressure sensing in industrial pressure vessels and industrial machines. And we are also seeing this in embedded distributed acoustic sensing, or DAS fibers, on public road systems for smart city solutions. So to conclude, DenseLight has a 20-year track record of serving both sensing and now the datacom industry. We believe we are one of the few remaining independent indium phosphide foundry with expertise on R&D and manufacturing. We are a leading global sensing light source supplier with customers across China, US, India, Japan, many parts of Europe and Russia. We provide end-to-end manufacturing solutions, and we have comprehensive IP that encompasses vertically integrated competency from wafer processing to system solutions. We have trust-based relationships with our customers. We provide end-to-end, flexible, on-time customized solution to deliver game-changing products. Our goal today is to become a world-class company for platform-independent or platform-agnostic laser light solutions. And we want to be the catalyst and enabler for the transformation for both the datacom and sensing markets as the industry evolves towards Industrial 4.0. Thank you for listening.